Welcome once again to another finance video. This one will also be in my others playlist. And now I'd like to look at a closed form solution for duration. In other words, a closed form solution that you could enter as a formula in a cell in an Excel spreadsheet. Okay, so let's look at this. Duration at date 0, duration, is the sum for I equals 1 to n of cash flows. C stands for coupon here. Coupon divided by 1 plus y to the I times I. And then if the bond has a life of 10 periods, this is going to give you 10 coupons divided by 1 plus y to the appropriate power times I. So first one times 1, second one times 2, last one times 10. But no mention of a face value here. I have a separate term outside the summation sign, plus 1,000 face value of all bonds divided by 1 plus y to the n times n. Okay, fair enough. It's a nice way of describing the numerator of duration. Here again, I'm separating coupons from $1,000. A little different than we saw in the last proof, but equivalent. Denominator's bond price. Once again, we're separating the coupons from the final payment. So we have the sum for I equals 1 to n of coupon divided by 1 plus y to the I, plus the face value payment of 1,000 divided by 1 plus y to the n. Of course, it's obvious, since we're seeing y, that the duration measure makes use of the yield to maturity approach to bond pricing. Okay, and that's not a strength of duration, not a strength. Now I make an observation. Note that the sum for I equals 1 to n of c over 1 plus y to the I times I, that's this. You can factor out the c, take it to the left of the summation. You have c times the sum for I equals 1 to n of I over 1 plus y to the I. Okay, so let's see. Roman numeral 1, an equation from finite series mathematics. Okay, let S equal 1 over 1 plus y. We're looking at this term right here. So when I is 1, 1 over 1 plus y to the first power. Default step is 1, so now I is equal to 2, so 2 over 1 plus y squared. Default step is 1, now I is equal to 3, 3 over 1 plus y cubed plus, excuse me, when we get to n, I is equal to n divided by 1 plus y to the n. That's our last term. We're done. You know, a finite number of terms. Now, the trick here in defining the sum to make it something that we can actually, put in a formula in a cell in an Excel spreadsheet, and we can't deal with these dots. And so we create a second equation. Roman numeral 2, multiply both sides by a factor. Again, the factor is 1 plus y. So the left-hand side I have 1 plus y times s, and here I have, of course, 1 plus 2 over 1 plus y plus 3 over 1 plus y squared, because I'm multiplying 3 over 1 plus y cubed times 1 plus y, so I get 3 over 1 plus y squared, plus plus last term, multiplying this by 1 plus y, you get n over 1 plus y to the n minus 1. Okay. With Roman numeral 1, left equals right. Roman numeral 2, that equation, left equals right. Logic tells us then the difference in the lefts has to equal difference in the right hand. Differences in the right hand side. The difference in the right hand sides, excuse me. And it's 2 minus 1. So 1 plus y times s minus s. And over here we've got 1. And nothing to kind of offset it with, that's fine. And then, look, we have 2 1 over 1 plus y's minus 1 1 over 1 plus y, so we're left with 1 over 1 plus y. And here I've got 3 1 plus y squareds minus 2 1 plus y, 2 over 1 plus y squared, leaving me again with 1 1 over 1 plus y squareds. And the next term would be 1 over 1 plus y cubed. And so the last term here that's going to stand out is going to be 1 over 1 plus y to the n minus 1. Because here I have n over 1 plus y to the n minus 1, and the term that precedes this one will be subtracted from that. It'd be n minus 1 over 1 plus y to the n minus 1, so I'm left with 1 over 1 plus y to the n minus 1. And then, since it's 2 minus 1 minus this last term, all by itself, minus n over 1 plus y to the n. Spend some time thinking about why this is what it is. I just explained it, but spend some time thinking about it. Now we work through the algebra, distribute the s plus ys minus s's cancel. So we're just left with ys over here. And then I'm going to leave this 1 by itself. I'm going to leave this n over 1 plus y to the n by itself. And I'm going to look at these terms. And lo and behold, we stare at those and realize, hey, that's just a PVIFA, where the opportunity rate of return to R is just called Y, and N, number of cash flows in the annuity, or terms in the interest factor, if you will, is equal to N minus 1. Well, okay, perfectly fine. Little unusual, but logical and correct. And therefore, I'm now going to divide both sides by y. So down here I have ys divided by y is s. Then I have this whole thing divided by y. That's down here in this funny looking kind of heart-shaped thing. But notice I have 1. And then this PVIFA is 1 plus 1 over 1 plus y to the n minus 1. Because that's the value for n. Kind of weird, but you see what I mean, over y, minus this last term, all over y. That's s. And very interesting, okay? And the next thing we do is we, again, make sure you see that what we've just done is we've kind of solved for this right here. We've restated that right there, okay? And that appears as this term in the numerator, okay? With the c moved to the left of the summation. Keep that in mind. And so now we're ready to say what the duration is. Duration is c, that c that's been moved out. You see it here also. That's c times this sum, which we just showed that this sum is equal to what we have s's shown here. 1 plus, then 1 minus 1 over 1 plus y to the n minus 1 over y, minus n over 1 plus y to the n. There we go. Plus this last term up here. Okay. Plus 1,000 divided by 1 plus y to the n times n. And then in the denominator, we have, again, we've pulled the c out. So we have c times the sum of 1 over 1 plus y to the I. We know what that is. For I equals 1 to n, not infinite. So we pull the c out, we get the sum for I equals 1 to n of 1 over 1 plus y to the I, and that's going to be a PVIFA. So down here, with the c pulled out, we have c times the PVIFA, 1 minus 1 over 1 plus y to the n over y. Okay, again, it's regular all the way to n, so that's why it shows like that. Plus we have the last term, 1,000 divided by 1 plus y to the n, plus 1,000 divided by 1 plus y to the n. So what you see down here, therefore DO, or D sub 0 equals all this. That is a closed form solution for duration, which can be entered into an Excel spreadsheet, and it's very helpful. And thanks for watching. That's all for this video.